Welcome to online maths lessons. Today I am going to teach you about how to solve quadratic simultaneous equations. In my previous video lesson, I taught you how to solve linear simultaneous equations. In this video lesson, you will see quadratic equation and linear equation together. You will learn how to find the solutions for x and y, which satisfies both the quadratic and the linear equation. Okay, let's learn how to solve quadratic and linear simultaneous equations algebraically. In this example question, I have a quadratic equation and a linear equation. How do we find the solutions for x and y which satisfies both these equations? A quadratic equation means at least one of the terms with the letters have a power of 2. A linear equation means the powers must not be greater than 1. In this case, the power of x is 1 and the power of y is 1. So this is a linear equation. Here in this example equation, both the x and the y terms has power of 2. But it only needs to be at least one term. Okay, let's learn how we can solve these two equations. Okay, first of all, I am going to label the two equations as equation 1 and equation 2. When we did linear simultaneous equations lesson on our previous lesson, we simply add equation 1 to equation 2 or subtract equation 1 from equation 2 in order to get rid of whichever the term we decided to get rid of, either the x term or the y term, depending on the signs and the number of x's or the y's. However, if you either add equation 1 to 2 or subtract equation 2 from 1, you won't be able to get rid of either the x or the y terms because the power does not match for either the x term or the y term. In equation 1, you have a power of 2 for the x and power of 2 for the y term. And here you have a power of 1. So it is not easy to get rid of unless you square equation 2. This way you can match the power of x term in equation 2 with the power of x term in equation 1. So that by addition or subtraction you can get rid of the x term or the y term, whichever the one you decided to square. Now I am going to square equation 2. Equation 2 square. On the left hand side, when I square it, I will have x squared, and on the right hand side you must square all the terms because an equation is like a balanced scale. Whatever you do to the left hand side, you must do the same to the right hand side. So it is not individual terms that you square, but the entire set of terms. That's why you have to put a bracket and then square all the terms. So on the left hand side I have x squared, and on the right hand side this is expanding double brackets. I write it as y minus 5 and y minus 5. So on the left hand side I have x squared, and on the right hand side now I am going to times each term on the left hand side with each term on the right hand side bracket. Y times by y is y squared. Then y times by minus 5 is minus 5y. Minus 5 times by y is minus 5y. Minus 5 times by minus 5 is plus 25 because minus to minus cancelled out. On the left hand side I have x squared. Now I simplify the right hand side. I only have one y squared term and there are two minus 5y terms, so that is equal to minus 10y after simplifying, and then plus 25. Now I can label this as equation 3. I have two equations now that have x squared terms and y squared terms, that is equation 1 and equation 3. You can now use equation 1 and 3 in order to get rid of one of the terms. Of course, looking at equation 3, you have a y term as well in addition to y squared term. It is not a good idea to get rid of y squared term because if you do so, then you will be left with x squared and a y term. You will struggle again to find a solution for. The easiest way to find a solution is by getting rid of the x squared term. The only x term in equation 1 and 3 is the x squared term. Okay, now I'm going to get rid of x squared term. How can I get rid of the x squared term? If I subtract equation 1 from equation 3, the left hand side of equation 3 is x squared and the left hand side of equation 1 is minus x squared minus y squared. When you subtract, the minus sign takes the sign of the x squared and y squared term. On the right hand side of equation 3 I have y squared minus 10y plus 25 and then minus the right hand side of equation 1 is 13. So this x squared to that x squared cancel out because that's equal to 0 then. On the left hand side I have minus y squared. When that moves on to the right hand side it will become a positive y squared. So on the left hand side I will be left with 0. This minus y squared moves to the right hand side and adds into this y squared, which will be equal to 2y squared minus 10y plus 25 minus 13 is 12. Then if I divide all the terms by 2 and then write all these in the left hand side, then it will be equal to y squared minus 5y plus 12 divided by 2 is 6 equal to 0. Okay, now I have to factorize a quadratic formula. Coefficient of y squared is 1. So 1 times 6 is 6. 6 is coming from this. This is the c term of the quadratic formula. So 1 times 6 is 6. Then see whether these will add into minus 5. They are not. I choose another number pair. 2 times 3. 2 times 3 is equal to 6. But they do not add into minus 5. They add into positive 5. So I choose minus 2 and minus 3. Because minus 2 and minus 3 multiplies into positive 6. And minus 2 plus minus 3 is minus 5y. So I can rewrite minus 5y in terms of minus 2y and minus 3y. So y squared minus 2y minus 3y plus 6 equal to 0. Then I factorize. I choose this pair and that pair. So take the y term, which is the y is the common term for y squared and minus 2y. So I take it out. Y minus 2. Because when you expand the bracket, y times y is y squared. Y times minus 2 is minus 2y. Then 3 is common to 3y and 6. So I write it minus 3. Here I take 3 out. Then it is y minus 2. Because minus 3 times y is minus 3y. Minus 3 times minus 2 is plus 6. So this is a factor. So y minus 2 and y minus 3 are the two factors. So the solutions are y equal to 2 and y equal to 3. Then I can go back and substitute y equal to into equation 2. So equation 2 is x equal to y minus 5. So x on the left hand side is equal to, when y equal to 2, 2 minus 5. X equal to minus 3. Substituting y equal to 3 into equation 2, x equal to 3 minus 5, which is equal to minus 2. The solutions are then, when x equal to minus 3, y equal to positive 2, and when x equal to minus 2, y equal to positive 3. Okay, now we have found the solutions for the quadratic and the linear simultaneous equation. Here's another example question for you to try at your free time in order to improve your understanding about solving quadratic simultaneous equations. In order to access my upcoming video lessons, please subscribe to my channel. Thank you.